So now we are into Unit 2, in which we will see basic PLC programming using basic functions, right? In that, what we will do is, the first part, I can divide this into two parts, part A, part B. In part A, what we will do is, after seeing basic function, we will solve some problems, some PLC problems. Okay, in which what we will do is, first we will recall or review our digital logic, okay, knowledge, right? After that, what we will do is, we will see how to transform this digital logic into PLC program. Okay, in part B, what we will do is, we will try to see how to write large PLC program, a standard procedure. After that, I will introduce you about timers, followed by few programs, followed by counters, followed by its related few programs. Are you ready for this?
Yes.
Okay, let us try to complete first part, that is PLC basic functions. This question is expected in exam, maybe for short answer or maybe a part of long answer, right? So on your screen, basic PLC functions. Okay. This is also called as basic input and output instruction. There are 5 basic input and output instructions. The first one is called as normally open. Contact, as I already told you, contact means input. And the second one is normally close. Contact means again input. So first basic function is normally open. Contact means belonging to input category. Second one is normally close. Again input category. Third one, latch and unlatch system. It is not input, it is output function. Then next, differentiating up, differentiating down. Yeah. Latch and unlatch system, they are actually input instruction but used at the place of output. Differentiating up is again another input instruction. Differentiating down is again another input instructions. Altogether, there are 5 basic PLC functions which we can use to what we can say, get the logic input instruction information from the outside world. Okay, let us start with the first one. Normally open. Its symbol is this one. The meaning of this is, when any sensor connected to this particular place, whose symbol we are using in PLC ladder program, okay, get the input, that is, if suppose it get close, then in that case what happen is the function carries out some kind of action. That is nothing but if true. The meaning of normally open kind of function is if true. And the second one normally close. The meaning of this is, its symbol is like this. The meaning of this is if false. Maybe I'm writing this C equivalent code. If true inside the braces, whatever we want we write. So here in this case, uh, uh, the meaning of this is the output get the high logic if true. If false means output get the high logic. In this particular case, by force, if we want to send, that is, it is like set bit instruction. Latch is just similar to set bit instruction, and unlatch is just similar to CL, clear bit instruction. I think you are aware of set bit instruction in microprocessor programming. What is the use of this? Suppose we have a bit like carry bit, Okay. We want to make it high. For that, what can we do? We will write this instruction CLRB followed by C. Then what happens? This carry bit become 1. Suppose later on we want to make it 0. Then what happens is we will write this instruction clear B followed by C. Then what happens? The carry bit become 0. Hope it is clear to everybody. In the same way, without getting the sense of input from outside world, from the sensor, from inside itself, if you want to forcefully make some of the coil on, we will use latch function. If you want to forcefully make some of the coil off, we will use unlatch instruction. Hope it is clear to everybody.
Yes.
Yeah. I will try to elaborate the meaning of normally open, normally close, okay, functions. Okay, in order to make it more clear, what I will do is, let we have A, B, and C, three Boolean variables, and suppose we have Y as these three are playing the role of input, and Y is a Boolean variable which is playing the role of output, and we have the function Y is equal to A, B bar, or A bar C plus BC bar. Okay. So in order to realize this type of logic in our ladder diagram using these two basic functions, this is called as normally open, this is called as normally close. What we will do is we'll write the logic like this, rung like this. For A, I will use like this rung A. For OR logic, I will write connection in parallel. Okay. Okay. A, B bar. For OR logic, this is OR. This is OR. For OR logic, what I will do is I will write the connection in parallel. A bar, and this is C, and finally for another OR logic I will write so all together give connection to output Y, right? So this type of input is called as normally open. This type of input is called as normally closed. In our digital electronics, we are calling this to be normally open. We are calling as active high. What it is called? Active
High.
high. And this is called as active
Low.
low. When low input is given to this thing, this become active. When high input is given to this type of contact, it becomes high. Hope this example makes you the understanding of normally closed and normally open function clear, right? Please acknowledge with yes, no.
Yes.
And how about this
Yes, sir.
realization? Is it clear to everybody? A C bar, A bar C, B C bar.
Yes.
Now, latch and unlatch system. It is used for permanent on. As I already told you, by force, I am using the instruction. I am imposing some logic. I am imposing some logic on the coil that is called as latch and unlatch system. With the help of some example, I will try to make it more clear. Okay, differentiating up. It makes the function on for one scan time at the leading edge of the activating signal. You see, suppose this is our PLC input module. It is having some common input, common point, and input number 1, input number 2, and so on. Let us suppose that a sensor is connected. Let us suppose that a sensor is connected between input number 1 and the common point as something like this. This is sensor number 1. One second. Let us suppose that we have like this. This is input connection. The common point is actually the point of positive supply. Okay. Okay. This positive supply to input 1 is actually control with the help of this sensor. With the help of this sensor. This sensor may make the contact or may not make the contact. If suppose this is making the contact, okay, then in that case you see the supply voltage from common is going into the input number 1. So inside PLC what we will do is we will write the program like this. Input number 1, suppose the input is coming at input number 1, input number 1, then what happened? Make the output Y high. something like this. I'm simply writing a logic. Okay. I'm getting call from Technical College HOD. Okay, just wait for me for 2 minutes. हेलो, अस्सलाम वालेकुम साहब जी। नहीं नहीं नहीं, कॉलेज में हूँ, क्लास ले रहा था, बोलिए। नहीं नहीं, एक सेकंड में रोक दिया क्लास। हाँ, ओपन इलेक्ट्रिक का देखिए, हमारे पास वो स्कैडा चल रहा है और एपीसी चल रहा है और पीपीडीएसएम चल रहा है। अच्छा, ओपन, ओके ओके, ओपन इलेक्ट्रिक पूछ रहे हैं ना? 8 का पूछ रहे हैं आप? सेमेस्टर 6 का? अच्छा, मैं मालूम करके बोलता हूँ इंशाल्लाह। हाँ, okay, can we continue? Let us see this thing. What is the meaning of differentiating up? How it is different from normal open, normally open function? See, differentiating up, differentiating down, there are actually extension of normally open functions. Normally open function. In order to make the difference between this and the differentiating up and differentiating down, first of all, I would like to make you more clear about the normally open function with respect to connection with the input sensor. Are you paying the attention? Are you on listening?
Yes, sir.
You see.
Yes, sir.
Yeah, by some mean, what we will do is, it may be any digital sensor. We will try to give a mechanical movement on this particular sensor. Because of this, what happened? The supply voltage will go into the input module number 1. So here in the program, I'm writing the program, use the input number 1. Okay, okay. Accordingly, make the output y high. This is what happened when we use normally open contact. If suppose we use differentiating up contact, in that case, what happen is we all know that because of the pressing of this thing, a pulse is created like this. A pulse is created. So this pulse will be on for some amount of time. After that, this pulse will become again low. This is about sensor 1. When we use differentiating upward at the leading edge, इसको क्या बोलेंगे? What is this point called? What is this point called? Leading edge. And what is this point called?
Trailing edge.
Yeah, trailing edge. So when we use differentiating up type of input, then what happened? This particular function make the scan time at the leading edge of the actuating signal, meaning the decision will be taken at the leading edge. If we use differentiating down, the decision will be taken at the trailing edge. Sometimes what happens is exactly at the starting of pulse, we want to make the coil on. In that case, it's suggested to go with differentiating up. Sometimes what happens is after giving the pulse, okay, at the leading edge, we want to actually trigger the output coil. In that case, we go for a differentiating down type of input. If suppose neither this is important nor this is important, we will go with normally open type of function. Hope it is clear to everybody.
Yes.
Yeah, these are all 5 different type of input function. I will make it once more. I will revise it once more so that it becomes very clear. There are 5 different types of PLC basic input functions. First one is normally open, which is just similar to our Boolean variable active high. Okay, so the text for this is when this contact closes, meaning when this contact get the logic, the function carries out some information. Otherwise, the function is not carrying out any information. In case of normally closed, the function will be keep on carrying the action. If suppose this get open, because this type of contact we will use if suppose the connection is already closed, and by applying the force the connection become open, meaning when this contact gets open the function carries out some kind of action, meaning already it was closed, the circuit become open. So in short, this type of function is just similar to active low of Boolean logic. Latch and unlatched type of system are actually used to permanently make the coil on or make the coil permanently off. Differentiating up, differentiating down are in general similar to normally open contact. Only difference is in case of differentiating up, the function carries out at the leading edge, and in case of differentiating down, the function carries out at the trailing edge. Hope it is clear to everybody.
Yes, sir.
Yeah, this is already completed. Yeah, already I told you output is represented with the help of these are the different types of outputs. Output are actually represented as coil or some indicator or something else. Its symbol is either this or its symbol is like this. Output is just similar to the output function of our Boolean equation, okay, which will be always either high or low. Always remember this thing. The output is there are okay, I'm sorry. There are two states of output function. One is high, which is called as energized. Another is low, which is called as de-energized. Right? Hope it is clear to everybody. Can we move
Yes,
further?
sir. Yes.
So far we have covered basic input instructions and output instruction. Now let us go into programming. Simple PLC programming with the help of these basic functions. Actually, in order to understand more clearly, you need to start working with the reference textbook. It's very difficult for me to give all possible exercises and then try to solve it. So I sincerely request you to have a textbook at your side, and whenever I refer to that, you should be able to see it. Hope a few of you got it. I want everybody to get it. Okay, let us start the first example. The first example. Example 1. Suppose we have one switch SW1, okay, call it to be contact, and we have one output, calling it to be coil. So we need to write a program with the help of one switch and one coil. Just now I have shown you, it is advised to draw input module connection and output module connection in addition to your ladder program if it is asked. In case of input module, there is one common point which carries V information, okay, and there are few inputs, digital inputs and analog inputs. Mostly we work from unit 1 to unit 4 on digital inputs only. So input module connection is like this. Output module connection. Suppose this is the bulb which is connected to output 1. Okay, this is the connection. Okay, can you please, one of you, comment on the connection? Able to understand this connection?
Yes.
This is input module. Okay, input module as well as output module is having common point. So common point is actually connected with supply. Suppose this bulb work on 24 volts. So 24 volt supply is connected from here. So ground supply we need to control from program. V is directly connected. Agree or not? थोड़ा आ जाओ क्लास में आप लोग. I want everybody to pay attention. This is very important. नहीं तो मैं आगे नहीं बढ़ सकता. Everybody please get into the class. Pay attention please. Hello, check me.
Yes, sir. Yes, sir.
Everybody acknowledge. Everybody acknowledge.
Yes, sir.
Yes, sir.
I want everybody. Girls, including girls.
Sir.
Uruj. Zainab. Mubina.
Yes, sir.
Okay, चलिए.
Yes, sir.
चलिए आ जाइए. You see, suppose we have a bulb, DC bulb, which work with 24 volt, right? So 24 volt supply directly we are applying, and we all know that we need to give, apart from this, ground also. That ground we are controlling with the help of PLC program. We always do like this one. High supply is already connected. Low supply is controlled with the help of PLC program. Agree or not?
Agree, sir.
Yeah, you see. What we need to do. देखो दुनिया की ऑटोमेशन की जनरल लॉजिक क्या है मालूम है? Sense data and accordingly perform control action. Data sensing can be done with the help of sensing a sensor. Okay, so in order to make this concept clear, I'm taking simple example. Let us do sensing from one simple sensor. Accordingly control the triggering of this bulb. मान लो अगर ये सेंसर क्लोज है तो क्या करो आप? Make the bulb low, right? If suppose this is off, तो ये भी off हो जाएगा. If this is on, ये भी on हो जाएगा. Internally how the things happen, try to understand that thing. मैं यहाँ से फिजिकल सेंसर को कनेक्शन दे रहा हूँ by some mean. So our PLC program is actually sensing that with the help of the program which is available. Okay, this is the program. So this is actually input number 1. So I will write over here, sense input number 1. Accordingly make output number 1 high or low. अब ये देखिए, simple logic. If input is high, output is high. If input is low, output is low. Yes, no. Is it clear to everybody? Then make a drawing, or you can do it later also. अभी कर लीजिए, अच्छा रहता. चलिए क्या करना चाह रहे हैं आप लोग? You want to copy this later? Can we go to next example? If it is clear.
Yes, sir, clear.
Next example.
Yes.
In this example, what we will do is, so we will try to increase the number of input from 1 to 2. Okay. One is suppose start, another suppose stop, two inputs. Suppose this is input 1 and this is input 2 and one output. Output is suppose our motor, say one output. Okay. The task is, you want to write or can I write that on board? Okay, the logic is like this. If start is press, suppose if it start is press, it is asked to energize the coil. And one more point mention is, okay, energize the coil. Second,
Stop.
huh,
De-energize.
yeah. One more thing. One important information. If a start is pressed, energize the coil. Continue this after releasing of बटन. जैसे आप लोग अपने घर का पंप का कनेक्शन देते, कौन सा इसका आपके वाटर पंप होता ना, पंप कंट्रोलर, एक बटन होता है, देखिए, वी ट्राई टू प्रेस इट. Okay, it is not push button type of switch. No, it is not on off type, permanent on and permanent off type of switch. Instead, it is push button type. We press it once. After that, there is no need to continue pressing. It will actually lock the logic and continue performing the control action. If you want to stop that, we need to press the stop button. The same type of logic we want to make here. That is, if the start button is pressed, energize the coil. Continue this action after releasing of the button. Which button? Start button. Hope it is clear to everybody.
Yes, sir, clear.
This is task 1. Task 2. The coil, okay, if stop is pressed, de-energize the coil. If coil is pressed, de-energize the. If stop is pressed, de-energize the coil. And it is also asked to do this program or write this program using two methods. Method 1 is using latch and unlatch. Method 2 using normally open and normally close contacts. Can we go for it? Can we go for this program?
Yes, sir.
I'm writing the program on the same screen. Let us use first latch and unlatch. Okay, this side. Our start is connected to input number 1. So if input number 1 is press, give a connection to latch. Suppose this connection is of memory bit P3 is to 0/0. If you don't understand this thing, no problem. Call it to be a memory bit. Then second line, straightforward, write on. Stop is input 2. If input 2 is press, then perform unlatch operation. So this action is again going on the same place. P3 is to 0/0, the same memory bit. Later, what we will do is we will write at last P3 is to 0/0 is actually going to update the output 1. Output 1. This is nothing but our motor. So this is the realization of circuit with the help of ladder program. Hope it is clear to everybody.
Yes.
हाँ इधर देखिए अब इसको मतलब क्या है बोला तो if input 1 that is start button is press lock the logic with the help of latch and store the logic in this memory bit. You see this memory bit is actually making the output high. If suppose stop is pressed, then this locking will be unlocked and that is done with the help of unlatch switch. Is it clear to everybody? Immediately after this session, what I will do is I will show you the simulation on simulation software platform. Is it clear to everybody?
Yes, sir.
Yes?
Yes.
Yeah. Let us see this with the help of second method, that is normally open, normally close contact. Okay. How can we write this program? We write this program like this. When input 1 is press, but input 2 is not press, then make the output y, output 1 high. अब ये समझ में आया नहीं है जरा बताओ.
आया सर आया.
If this is yes, yes means normally open. And this is no, no means normally close. Then make the motor which is connected to output 1 high. But in this, we also need to perform this important task. How can we do that? If suppose input 1 is press, continue making output 1 high even though this is not continuously pressed. There is a need to lock this thing. How can we do that? That we can do with the help of very simple task called as feedback. So क्या बोलेंगे अपन? Feedback. Feedback. Feedback is used to seal बोलेंगे उसको. Seal the logic. This is the key point. Feedback is used to seal the logic. अब ये देखिए, एक मर्तबा इन्हें प्रेस हो गया, या आउटपुट हाई हो गया. अब क्या करो मालूम है? इसको सील करने के लिए आउटपुट में से एक फीडबैक लो, लेके इधर ही लगा दो. सील हो गया. Is it clear to everybody? Yes, no?
यस सर.
Yes, sir.
तो फीडबैक जो है उसको अगेन लगाना जरूरी है सर वहाँ पे.
हाँ, फीडबैक लगाए तो सील होता है, नहीं तो नहीं होता.
अच्छा.
अभी इधर देखो कैसा काम करता है. इधर देखिए आप, समझ जाओ. स्कैन 1, फर्स्ट स्कैन में, स्कैन 1 में समझ जाओ आउटपुट 1 हाई हो गया. अब स्कैन 2 में इधर देखिए, आप गौर से देखिए, स्कैन 2 में लेट इनपुट 1 इज 0 है, इनपुट 1 इज 0 है. सो हाउ अबाउट आउटपुट 1? बट आउटपुट 1 प्रीवियसली 1 है, इस वजह से इट इंप्लाइज न्यू आउटपुट 1 विल बी 1. इधर देखो, कुछ भी नहीं. इधर देखो आप, स्कैन 1 में आउटपुट को कनेक्शन यहां से जाएगा, चले गया, गया नहीं गया?
गया सर.
तो इन्हें क्या बन गया? 1 बन गया.
1.
स्कैन 2 में इन्हें ऑफ है, तो कनेक्शन कहां से जाएगा?
आउटपुट 2.
यहां से जाएंगे, नीचे से. ये पाथ दे रहे हैं ना आप, जाके फिर आउटपुट 1 को 1 कर देंगे. That is the logic. This is very very important.
यस सर. आगे.
Okay. इसका इनपुट आउटपुट मॉड्यूल ड्रॉ करेंगे आप लोग? Would you like to draw input output module of this circuit? ये अगर इनपुट मॉड्यूल आउटपुट मॉड्यूल ड्रॉ करना आ गया ना, आप लोग डिजाइन इंजीनियर बन जाते हैं. सीधा पीएलसी को कनेक्शन देना आ जाता आप लोग. यहां से क्या मिल रहा है आपको? यू आर गेटिंग वी. इनपुट 1, इनपुट 2. इनपुट 1 में क्या लगे हुआ है बाबा? व्हाट इज कनेक्टेड टू इनपुट 1?
SW1.
स्टार्ट. एंड व्हाट इज कनेक्टेड टू इनपुट 2?
स्टॉप.
Stop. Okay. How about output module? This is same as that of the last case. Common, which is V. Output 1 is actually connected to the other point of the output. This is called as connection diagram. क्या बोलेंगे इसको? What is this called? Connection diagram. Can we move further? Yes, no?
Yes, sir.
Yes.
Let us suppose that task 3. Let us suppose that you want to add one more input to the last program. Input 1, start. For forward request. Input 2 is to run the motor in reverse direction. Okay. Then input 3 is to perform stop operation. try to increase some output also. First output is forward output. Second output is reverse output. Reverse output. Let us see the case of our elevator. We want to run elevator in both direction, forward as well as reverse direction, right? So how can we initiate this in our PLC program? Is given as exercise number 3. I hope you can understand this thing. So I'm leaving this to you for practice. कर लेंगे आप लोग ये? Should I show this thing?
Sir, please show this.
Okay. So this diagram I'm not going to draw for this case. Okay, चलिए read करिए. We will write two runs, one for forward, as we have how many output, जितने output रहेंगे उतने runs रहेंगे.
Two outputs.
Please always remember this thing. दो output रहेंगे तो कितने runs रहेंगे भाई? Number of runs will be 2. Okay. If request is forward, forward को क्या नंबर दिए बाबा? Input 1. अब जो लिखते लिखिए आप. Input 1. And और क्या लिखेंगे? What else we can write? For start yes रहना, stop no रहना. Agree or not?
Agree, sir.
Start yes, stop no. So finally output 1, that is nothing but forward running is high. Okay, how can we seal this logic? Seal the logic by writing a parallel connection to this input. So this logic is sealed. I'm leaving one space for introducing one concept that I will tell you in just a moment later. Okay, next, for output 2, how can we write the logic? Jaldi se bolo, please, from your side.
Sir, start reverse.
Yes. Start reverse.
Then one stop.
And not stop. Okay.
Output 2.
Output 2, because we need to seal the logic. अब इधर देखो आप, जब मोटर फॉरवर्ड डायरेक्शन में रन कर रही तो रिवर्स डायरेक्शन में रन करना नहीं करना?
करना सर, करना
नहीं करना. दैट इज कॉल्ड एज इंटरलॉक.
रिवर्स है ना?
देखिए ये एक बात सुनिए मेरी. अगर समझ जाओ आपको मोटर फॉरवर्ड डायरेक्शन में रन करना है तो रिवर्स डायरेक्शन को ब्लॉक करना पड़ता नहीं करना पड़ता?
करना पड़ता है.
तो क्या करेंगे मालूम है? यहाँ एक और एक लॉजिक डालेंगे, नॉट दिस वन, नॉट आउटपुट 2. और यहाँ क्या डालेंगे?
आउटपुट 1,
नॉट आउटपुट. राइट? Okay. So take 5 minutes or in fact take 10 minutes break after that. We'll continue. Right?
Okay, sir.
Yes, sir.